Welcome to this webinar, which is co-organized by the ECSCI Cluster of European projects on critical infrastructure protection and resilience and the EU-CIP coordination action. I am John Soldatos. I'm a member of the EU-CIP project from company Innovators. And today's today's seminar is on a very topical theme: how we can leverage artificial intelligence to improve the resilience of critical infrastructures. But also, and I want speakers to take one moment to it, even if it's not in all the presentations, if the introduction of artificial intelligence in critical infrastructures for protection purposes raises some additional vulnerabilities. So I don't want to ask you explicitly, but please, if you can find few seconds, refer to these questions. Yes, this is the agenda for today's webinar. The webinar is recorded and will be shared through different channels, including the EU-CIP Knowledge Hub. This is the agenda. We have two sessions. We organize the seminar in two sessions. One session is focused on detection, and the other is on intelligence and response. I know this is not a very strict distinction, but it's a sort of classification we can use for today with some freedom. We're going to start with a presentation from our two project. In the meantime, I want to finish the short intervention by saying that it's very good to connect to EU-CIP and keep track of resources we provide to the community, including also contributions for your projects. So we have a YouTube channel, a very powerful LinkedIn with thousands of subscribers, and also our Knowledge Hub, which is a single entry point to all our resources. So take some time to connect, and you will be also informed about upcoming webinars. So we're going to have a webinar on standardization, but also I'm going to come back to one of you colleagues with
Guarda che sei mutato, zio.
You mute yourself.
I will ask Federico to mute. It's also a request from me and Haptamu to, and we ask every speaker, but of course this is up to you. If you can provide a 2 or 3 pages contribution text on your presentation, we will be able with Haptamu to prepare and publish some proceedings, and we're going to make sure that these are open access. They have a digital object identifier, so it's useful for you and your projects. So if you have this willingness, just type this in the chat, and we'll let you know if you are okay providing 2 or 3 pages for the contribution. Haptamu and myself will find a way for this to publish. Sorry for talking too much. I would kindly now ask Sergio to share his presentation, to introduce himself and his project, and proceed with the first presentation, which is about unmasking threats, leveraging AI for advanced persistent threat detection from R2D2 project. Sergio, the floor is yours.
Okay, thank you. I'm going to share my screen, and if you can confirm me if you wait a minute. Wait, sharing. Okay, you can confirm if you can see it and you can hear me too. So everything is ready?
Thank you.
Yes.
Please, the floor is yours. You introduce yourself and your project.
So, well, hello everybody. I'm the first speaker, and welcome to this workshop, Artificial Intelligence. My name is Sergio Villanueva. I'm from Spain, and I'm working at the cybersecurity company S2 Grupo, or S2 Group, in the research and development department. This presentation will cover APTs. Don't worry if you're not familiar with the term, we will explain it later. And how we can use new technologies like artificial intelligence to help to detect them. The tool we will be discussing today is part of the development for one of the pilots in the European project R2D2, in which we are one of the collaborators. Let's take a quick look at the agenda for the next 15 minutes. We will begin with a briefly overview of the R2D2 project with objectives and the specific pilot we will be focusing on. Next, we will explain what APTs are and why they are particularly harmful and dangerous and harder to detect compared to regular attacks. And finally, we will explore the approach developed to detect APTs using artificial intelligence. That's why we are here. From its general architecture to more tool-specific details. So the European project we are part of as one of the collaborators is called R2D2, which means Reliability, Resilience, and Defense Technology for the Grid. And apart from being a Star Wars reference, a bit forced, if I may say so, its main goal is to enhance the resilience and reliability of current electrical power and energy systems. And especially when dealing with some kind of problems like physical, that you hear, cyber, weather, or even natural disasters. Our focus here will be on the cyber aspect, which is covered in the PrEP pilot, which means prevention system for energy infrastructures and security. And this project is also it has received funding from the European Union's Horizon project. So let's go with that. What's it an APT? An advanced persistent threat. This term describes an attack campaign where an unauthorized user, usually a group of people with economic or political interest behind, gains access to your network and remains undetected for a long period of time. Their primary goal is to steal data rather than to cause immediate damage to the infrastructure. And another keyword we must be familiar with is threat hunting, because well, it's seen as the proactive search for hidden cyber threats that go undetected within your network. So now that we already know what's an APT, let's dive deeper into how they work. I'm far from being an expert in this field, but I'll try to simplify their life cycle to understand why they are so hard to detect. The first step, well, here you have the life cycle I'm referring to. The first step is the recognition process. The attacker choose their target, and they gather information about them. We have the initial intrusion. More often is achieved via phishing or even exploiting vulnerabilities. After that, there are some phases of persistence to maintain the access, privilege escalation just to have a higher level control, or even lateral movement to compromise other systems. And once the attackers, they have enough control over your organization, they start with the data exfiltration part, where sensitive and privacy data is stolen and it's transferred out of your organization. During all this process, they use a lot of evasion techniques just to remain undetected. And the cycle is repeated over and over until they got what they need or until they are detected. But because of this evasion and highly sophisticated techniques, any additional help is very, very valuable for the defenders. And this is where the MITRE attack matrix comes into play. I don't know if you pronounce it MITRE. In Spain, we say MITRE attack, but I'm pretty sure that it's not correct. So we will say MITRE. This matrix is a public available database of tactics, techniques, and procedures that adversaries use to achieve their specific objectives. And this framework is very important because it provides us a common language and allows us, the organization, to understand and map the different steps that attackers take during the cyber attack, and to prepare their own defenses against those small steps. Here you have part of this matrix. It's bigger than this, but you can have just a quick view. The columns that you see here are the tactics that I mentioned, and you could see some of the one I mentioned before during the life cycle, like lateral movement or defense evasion, etc. And each of these cells represents a specific technique within the corresponding tactic. And what can we do with this information? Well, using this knowledge from the MITRE attack matrix and obviously combine it with the expertise of our analysts, in ECSCI Group, we have developed Carmen. Carmen is our own solution for APT detection. So if you allow me just a minimum of publicity, Carmen protects organizations by acquiring, processing, and analyzing your network traffic to detect anomalies and misuse. And all this is done through analyzers based on MITRE intelligence, and they help us to identify dangerous situations. And we want to improve Carmen's accuracy and efficiency. So what we are proposing here is the development of an artificial intelligence module as a complementary tool to have more resources to defend ourselves. So this is how the S2TH tool was born. It just means it's a combination of group or S2 group and hunting. And here we have this workflow can be summarized in a higher level overview here in this figure. So we have data coming from different resources such as power plants, networks, computers, IT devices, etc. All this data is processed and filtered, and our Carmen tools, Carmen Analyzer will act on this data just to try to find and detect potentially dangerous situations based on this processed data. And with anomalies detected by Carmen, our new tool will work through an API to identify scenarios with possible links to APT groups. And how do we achieve these things? Well, our model will take as input the historical threat intelligence that we say here, that the baseline intelligence against which to compare, and compare it with the Carmen output analyzer to correlate both sources and find similarities. And this similarity detection is performed using the artificial intelligence algorithms, specifically the natural language processing techniques, or NLP, as we call them. Finally, the output alerts, the generated alerts, are sent to a correlation engine that estimates an overall APT risk. And this is the tool's functionality in a nutshell, yeah, most of it. But before we can do this similarity finding, we have to correlate the data. And before that, it's essential to standardize the output from analyzers, from Carmen Analyzer, to align it with the threat intelligence, with our baseline intelligence from APTs. Think of it like if we starting with a disorganized desk with information coming from different sources or from different people, and we need to organize it before we can effectively work. So what do we need to bring an order? Well, it's so important. We need a manual. We need a manual that guide us and tell us what to group, what to remove, what to put in each row, etc. In terms of our project, this manual is created with the security teams, which help us with defining labels, defining parameters, sentence structures, negation operators, and so on. But we can get rid of this normalization process because once we have the manual, we can create a generative artificial intelligence agent that, using the rules, having access to MITRE information, and providing him several standardized examples to learn from, just to do the same thing, you perform that normalization process. So now let's move on to the artificial intelligence component. Once we have the baseline intelligence standardized, here you can see some examples. They are in Spanish, but they are easy to follow as petición is request, ejecución is execution, and here you see like a standardized mode. So we're gonna project all this data into an n-dimensional space, and we do it using natural language processing techniques. What you see here is a 3-dimensional representation, but just for visualization purposes, but because in reality, we are working with hundreds of dimensions and we can't even imagine that. So this special projection, if you notice, it can even provide us a map of APT group activities, which can reveal relationships between them. For example, it might show us that the same group, the same APT group, is behind multiple APT campaigns. And let's look now two NLP techniques that would help us to generate this projection. The first one is a bag of words. Okay, this is really simple. It's a simple method, and it consists on representing text as a collection of unique words. Ignoring grammar, ignoring word order, it just simply counts word occurrences. Here you have an example. I like oranges. Do you like oranges? We don't have the word apples, so we have a 0 frequency. We do have one do, just one. We do have 2 likes, and that's all. So you see here, it doesn't matter the order because it's the same. I like oranges. Do you like oranges? Do you like oranges? I like oranges. It's gonna be the same vector at the end of it. So it will make it easy to compare documents based on word present, and repetition. And to enrich this model vocabulary, we will train it with a lot of input data from multiple organizations just to have more variety in it. The second method we want to talk about has the same objective, is just to achieve a numerical representation of the words in our set of documents. But this one is based on the idea that the meaning of one word can be inferred from neighboring words. Okay, so in this case, we train a neural network model that will try to infer the meaning of a word based on its surrounding words, capturing those contextual relationships. It uses one-hot vectors. If we have a vocabulary of size M, one hot vector means that if I'm analyzing the third word of my vocabulary, my input vector will be a null vector, except in the third entry that will be just one. And what it does the magic inside, and after all, it will return me another vector with the same size, but each of these entries will tell me the probability that my initial word, just appear in the same context as the word that is located in that position of the vector. So using those two algorithms, we're going to have our projections. And as they are different approaches, because this one takes into account the grammar structure and the order, both can be used to detect in their respective space to do the similarity process. So one focus on keywords and the other one on the structure of sentence, but they can be correlated and they can be combined to be used together. Now, when we are working with Carmen, every time we take and analyze our output, we will apply the same NLP technique, the same NLP process, because this will allow us to represent this new data into an n-dimensional space, into the same one. So there we can measure distances, we can identify relationships there. And for example, here at the start represents one output, one analyzer's output. So if it's close enough to a known thread, because all those points represents APT activities that we have previously recorded and just projected into our space, well, a possible correlation is identified, indicating signs of an APT. And of course, you could tell me, okay, but this process could also be approached using generative AI. And I say, yeah, we could do it like this because we've seen related problems where it works. But is it really necessary? I mean, imagine if I have to cut a piece of paper in half and I'm using a high technology laser. Okay, well, the laser cut might be impressive, but scissors will do the job just as well. So maybe the extra resources are not justified. And additionally, in this case, this involves sensitive and private data from organizations. So running a large language model, running a generative AI would require significant resources within our environment. We have to run them locally. So it's expensive. And besides, in our project, in R2D2, Carmen is already sort of run out of resources. So if we can reduce the size of our tool, it's very appreciated too. And with our approach, we have an encapsulated tool, a small one that is far lighter and more resource efficient. So just to close this presentation, here's an illustration of how the model works with real network traffic. In the first sample, you have that star that is an isolated case, so there's no match. We don't have it. However, in the second one, we see a clear relationship between the output analyzer and the APT baseline intelligence that we have here. And you can see that it's like a PowerShell command line that we have here too, with the same policy execution. So, well, probably here is the colors are not very well chosen because you don't want the green one in your organization because of what it may imply. But, well, it's just to show you how it works, and because this star will be surrounded by some APT activities. And that's all. Thank you so much for your time. I just put here one blog. This link redirects you to a blog where the tool is discussed in a bit more detail. In case anyone is interested, maybe it's helpful for John because he said before that he wants us to write something. Maybe here it could be enough for us. And thanks for your time. I hope you enjoyed. I hope you enjoyed the rest of the presentation. And in case you have any questions, it's time for it. Thank you so much.
Very much, Sergio. Let me, for the presentation, thank you twice for keeping the time. May I ask if there is a question for Sergio? You can type your questions on the chat or raise your hand and ask a question. Anyone want to ask a question? Yes, please, Adriana.
No, there is a question on the chat.
Okay, thank you.
How can I access the chat?
How do you fine-tune your embeddings in terms of similarity metrics? It's a question from Ernesto. If Ernesto, you want to speak, you can.
Yeah, well, we are using like word-to-vec and bag-of-word models just to do that embedding that converts our documents to vectors, and we train it with a lot of input data from different organizations because we want to have a bigger vocabulary. And in this case, we build it on our own because it's a very specific problem. I mean, we are working with command lines, we're working with paths, computer path, we're working with executables, programs, and all those things. So we just do that fine tuning, do the training part, and after all, we use the cosine metric to find similarities in our space because we just want to see if they are just pointed to the same direction, and that's how we do it. And we just define some kind of threshold just to check and to assure that something is very related to that APT activity.
Thank you, Sergio. By the way, have you tested maybe in your lab, or do you plan to test how this could work with some LLM like GPT-4 with some security data, as you said, Mitre, or other domain-specific data, and whether it has a better performance? Because for me, it would be a very interesting exercise for
we have tested.
Performance would surprise you, but
we have tested, and it does a really good job. But it's the problem that I mentioned before, that we have limited resources. We cannot have a generative AI agent working all the time because it works in real time. So it's going to be just using those resources all the time. And we are having that problem in our project because we have a virtual environment with limited resources, but it really works well because it's quite well just doing that comparison between the baseline and the input data.
Thank you very much, Sergio. I guess you will be around also in the end if somebody has a
I'll be
question.
around here.
And if you give us some pages, we'll see with Haptam how we can create some proceedings. And next is AI for Cyber. Dr. Adolu Panagiotis, the floor is yours. Introduce yourself, your project.
Thank you very much, John. Hello, everyone. This is Panagiotis Valpromatikis from University of Western Macedonia, representing the AI for Cyber project. Let me share, please, my screen. Just a minute. You can see my screen, right? I think so, right? You can see my screen.
Yes, we can see.
Okay. Thank you very much. So, as I said earlier, I'm representing the AI for Cyber project. AI for Cyber aims, in general, to provide a set of AI-powered intrusion detection, mitigation, and preparation mechanisms, including, for example, AI-based vulnerability assessment regarding code analysis, intrusion detection, mitigation, threat intelligence, and cybersecurity information sharing across relevant stakeholders. Today, I'm going to focus mainly on the federated intrusion detection system provided by the AI for Cyber project. Some introductory information before going ahead with respect to federated intelligence, given the revolution of the smart technologies and the necessary integration of legacy systems, the presence of both intrusion and anomaly detection services is necessary. On the one hand, the smart technologies might raise new vulnerabilities, and on the other hand, legacy systems are characterized by, let's say, insecure communication protocols that do not include essential authentication and access control mechanisms. Characteristic examples are Modbus, EX104, Ethercat, DNP3, etc. So, although also that there are some cybersecurity solutions that can mitigate such effects, still privacy issues remain regarding the stakeholders that adopt, that leverage these cybersecurity solutions. So today we're going to see how, let's say, federated learning can enhance the cybersecurity mechanisms, and more specifically the intrusion detection services in terms of protecting the sensitive data across multiple collaborative stakeholders, of course allowing also a collective intelligence across these stakeholders in order to generate, let's say, more powerful intrusion detection models. And finally, federated learning is a weapon in order to comply with EU regulations. So, regarding the life cycle of federated learning, we have mainly in AI for cyber two components, the federated server and a set of federated clients. First, a global model is initialized by the federated server, and its training parameters are sent to the federated clients. Then each federated client is responsible for the local model training process, and after this process, the parameters of each local model from each federated client are sent back to the federated server. Then the federated server is responsible for aggregating all these parameters with each other and generating a global federated model, which is eventually returned to the federated clients. And this global model can be used for in production environments for detecting both intrusion or anomaly or potential anomalies based on the operational context of each case, of each environment. Regarding the architecture of the federated intrusion detection system implemented in AI for cyber, it is a multimodal federated intrusion detection system which is composed of 4 different detectors: the network flow based FIDS, the log based FIDS, the operational data based federated intrusion detection system, and the visual based federated intrusion detection system. The first one is responsible for detecting potential cyber attacks by leveraging network flow statistics, either TCP/IP based network flow statistics or specific application layer based flow statistics. On the other hand, the log-based federated IDS is responsible for analyzing system logs and identifying relevant intrusions or anomalies based on the data of each case. Operational FIDS then uses, let's say, raw measurements from each operational environment, such as, for example, in the case of a power grid, energy-related values are used in order to identify potential safety issues, not intrusions or cyber attacks, but let's say operational anomalies. And finally, the visual-based federated intrusion detection system uses virtual representations from network traffic data in order to identify the presence of a potential malware. Finally, in order to allow the federated learning process across the various stakeholders, the various environments, entities. A dedicated component for this purpose has been implemented called T for Federated Resource Index System, following the life cycle mentioned earlier. Now its detector mentioned before follows, let's say, a similar architectural design. First, there is a log collection module, a data collection module responsible for gathering the respective data, either, for example, network traffic data, system logs, operational data, or other types. Then this data is processed by the data pre-processing module in order to clean the data, to normalize this data, and or standardize them. Next, the processed data are used by the detection engine, which is responsible for applying the already trained federated model for the detection process, and based on the detection outcomes, the final module called security event generation and notification module is responsible for generating the respective security events utilizing the sticks format. Of course, this architectural design is related explicitly to the inference of the federated AI models, while regarding the training, the federated training, as I said earlier, there are two components, the federated server and the federated clients. The federated server is responsible for orchestrating the entire federated learning procedure, while federated clients focus mainly on the local training. For this purpose, for this architectural design, we have adopted the methodology of a relevant IEEE standard called IEEE Guide for Architectural Framework and Application of Federated Machine Learning. Okay, a common challenge regarding the effective use of federated learning, not only in the domain of cybersecurity, but actually in every domain, is the data heterogeneity. Let's say in terms of the presence of non-identical and identifiable features. And this means that if there are such data, the efficiency of the relevant of the global federated model in the case of some clients will not be effective in terms of accuracy, F1 score, true positive rate, or false positives. So in order to address this challenge within the federated learning procedure, we have implemented in AI for Cyber a custom aggregation technique called statistical averaging that uses more or less some simple statistics in terms of the mean and standard deviation from each client in order to aggregate all the weights, all the training parameters provided by each federated client. Based on some experimental results here, we can see that statistical averaging can overcome other well-known federated aggregation techniques, like, for example, federated averaging, as we can see in this diagram. Also, I would like to comment that statistical averaging now is integrated into the Flower framework, the most known and operational framework for federated learning. We are in the process of integrating this algorithm, this mechanism, in the libraries of the Flower framework, and of course it will be publicly available for the community. Now, I will have the time. I would like to show a relevant demo of our federated intrusion detection system. In this demo, actually, we can. The goal is twofold. First, to show the effectiveness of federated intrusion detection system to detect potential OCPP-related attacks. OCPP is an application layer protocol used within energy, actually electrical vehicle charging infrastructures. And the second goal of this demo is to show that the global federated model is, let's say, resilient against the effects of potential adversarial attacks that target ML models in terms of trying to misleading the decision making process of them. So let me show you the demo, just a minute.
Is to the
Can you see can you hear the sound? I don't know.
Yes, we can see the video.
Yes.
Okay, great. So, okay.
It seems there is no sound.
Sound? Just a moment. Let me stop sharing and start again.
There should be an option to share sound, Panagiotis.
So is there such an option? I don't know. From the browser?
There is a box in the desktop version which says share computer sound.
Unfortunately, I'm through the browser, not
okay, so
the
maybe you have to
application.
narrate a little bit your video, okay?
Yeah, okay. I can send the link in the chat. Okay, I sent the link. I think that now possibly you can hear the sound. In just a minute.
No problem,
Goal
Panagiotis.
of this
No
demo
problem.
showcase the detection efficiency of NFIDS and its resilience against adversarial attacks. Therefore, this demo is composed of 4 parts. First, the objectives of this demo are presented. Along with the objectives, next, the relevant attacks are discussed. Then federated training and inference are demonstrated. Based on the second scenario of use case 1, the first objective focuses on detecting cyber attacks against the Open Charge Point Protocol communications, leveraging federated learning. The goal of federated learning in this case is twofold. First, to leverage the data of each electrical vehicle charging station, and second, to ensure their data privacy. For this objective, the experimental testbed of PPC is used, considering two cyber attacks, namely session establishment denial of service and heartbeat denial of service between the electric vehicle charging stations and charging station management system. The second objective of this demo is to showcase the resilience of the federated model against adversarial attacks. For this purpose, before the federated training procedure, the FGSM attack was executed by a malicious insider against the first electrical vehicle charging station, thus producing the adversarial data and replacing the original dataset of this station with the adversarial one. Based on the previous remarks, the federated training by T for FIDS is demonstrated next. A real testbed is utilized for this purpose with one federated server and 3 federated clients. The top left terminal displays the federated server, while the remaining terminals correspond to the respective federated clients. The overall federated training includes 25 rounds, while federated averaging was selected as an aggregation strategy in this case. As shown, the federated server successfully initiates the federated training procedure, while it is worth reminding that the first client uses the adversarial dataset generated by the FGSM method. After the 25 rounds, the global federated model is generated and returned to each federated client automatically, including knowledge of each federated client in terms of aggregating the parameters of their local models. Despite the adversarial dataset and model of the first client, the goal is to demonstrate that the global federated model can successfully detect OCPP cyber attacks during inference. After federated training, inference follows, including traffic sniffing, aggregation, detection and security events generation. While the attacks are executed, traffic sniffing is used to capture the OCPP packets. Next, aggregation provides the flow statistics utilized by the global federated models during inference. Finally, the respective security events are generated. As shown, the session establishment and heartbeat denial of service attacks are successfully detected by the global federated model. Based on the experimental results, it seems that the FGSM method can affect the detection efficiency of the global federated model. However, it still can recognize the OCPP attacks with a sufficient accuracy of 0.8547, while the F1 score is equal to 0.8326. The next goal of AI for cyber is to investigate and create custom aggregation strategies that may further minimize the impact of adversarial attacks.
Okay, this was the demo. I hope that you can hear it. So that's all from my side. Of course, if you have any questions, any comments,
Are there any
feel happy
questions,
to answer.
Panagiotis? So apart from the resilience benefit, you also proved that your global model performs better, right, than each one of the local.
Yes.
What was it? Was some deep neural network with averaging of the weights?
Exactly. That's the case. MLP networks, deep MLP networks, for each client with the same exact architecture of the model. So we are talking about hierarchical federated learning. This means that all the clients have the same architecture in terms of layer and configuration settings from regarding the neural networks, MLP networks, and the global model indeed can achieve a better performance.
And there is a question in the chat. What about the explainability of this approach? How do you give insight to the operator of why or how this anomaly was spotted? This is a question, by the way, from Fu from Sintef.
Yes, actually, there is a dedicated component in AI for Cyber called Trust for AI.xi component, which is responsible for the explainability of the decision-making process made by the federated models. This component actually can explain the decision taken by the federated models through feature importances, and let's say through via a relevant dashboard, the end user can understand in terms of the significance of each feature how the model can take the appropriate decision. And this is applicable for both local and global explanations.
Another question from Dr. Vulkidis in the chat. What is the position of the product users when it comes to federated learning? Is it something that they are keen on using and adopting versus classical learning? Or are they willing to contribute to this federated exercise?
Yes, actually
Yes.
now.
Yes, please.
Exactly. They would need to actively participate, share data in whatever format and whatever privacy preserving considerations that have been taken. So one thing, of course, is the data homogeneity and the models homogeneity that needs to be tackled, which was actually handled by Panagiotis. The second one is something that we see in various projects, the fact that users, in many cases, are not willing to actually participate in this federated learning schema. Is it the case?
Yes. Yeah, please, Artemis, go on. Sorry.
No, that's it. So is this the case as well in this project or not?
Yes, actually, this is true. For example, in one of our use cases related to the finance sector, on the one hand, federated learning seems, let's say, a bit complex process, despite the fact that by the nature of federated learning, in terms of aggregation techniques, privacy issues can be eliminated, and also there can be encryption techniques or anonymization techniques like homomorphic encryption and differential privacy that can further improve, let's say, the privacy protection. However, let's say regarding the adoption by the end users, this is still a complex task because, let's say, we need a more user-friendly environment in order to allow federated learning to be, let's say, a usual process for the end users. And actually, this is done in the second period of the project to allow the end users through understandable and user-friendly dashboard to execute the federated training procedure by themselves without, let's say, any AI expert, more or less.
So we have more questions. I would like to apologize. I think we have to move. Please, Panagiotis, I beg you to have a look at the questions in the chat, give answers, and we will come back discussing these questions at the end of the webinar, given the time. And now I would like to pass the floor to Lazarus, to Dr. Patsakis, Professor Patsakis, Athena, to present. Also, as Kostas is preparing the presentation, I want to stress another comment in the chat from the coordinator of EU-CIP, Emilia. You can take 5 minutes for all of the solutions, Sergio, ADT, the federated learning by IFR-Cyber, and fill in a form and help us publish these solutions in our Knowledge Hub. So then we can promote it through our channels to the thousands of contacts we have in the community. So take 10 minutes to do this. Please, Kostas, the floor is yours. I just wanted to say this, and I will follow up. In the meantime, Panagiotis, have a look at the chat. Thank you,
okay,
Kostas.
many thanks, John. I think that now you can see my screen.
Yes.
Perfect, okay. So my name is Konstantinos Patsakis. I'm an associate professor at the University of Piraeus and an adjunct researcher at the Athena Research Center. I'm also the coordinator of the Lazarus project. And practically we are going to show some of the stuff that we are doing and why in this short presentation. So the project, the full name is Platform for Analysis of Resilient and Secure Software. So our main goal is to target on software vulnerabilities, how to detect them, how to patch them, and how to report them. The main motivation is shown here. So practically here you can see the CVEs, the vulnerabilities per year, and how they have evolved. You can see here that you have, you can say, a milestone which is situated around 2017, and you will see the big surge in the CVEs. The main reason why this happened is not because developers became more careless and started doing fancy stuff for their code, nor the fact that the software was doubled in terms of quantity. The main issue is that at this point they had to report, and this was more or less enforced by GDPR and then PPD 41 from the other side of the ocean. So practically organizations had to report what are the vulnerabilities that are happening. So why do you need Lazarus? So we haven't tried to create a new tool or a platform to, let's say, sweep everything that you have from your side, but create a toolkit that it's able to adapt to the existing pipelines. Or when I'm talking about pipelines, I'm talking about software development pipelines. So practically each organization has established some pipelines in order to create software, to deploy it and test it. And nevertheless, the software aspect, as I'm going to discuss afterwards, is often missing. So what we consider is that people should be able to pick and choose the tools that are fitting best to the pipelines of an organization, so that it's easier for them to adapt from what they currently have, which is DevOps, to something which is DevSecOps. So it is common that most of the tools that currently exist are mainly static, meaning that they try to see the code, the deployed solution, but not executed. So one of the core aspects is whether people are testing in terms of security, the platform when it is running. And when I mean testing, I don't mean only the penetration test that might go before, let's say, release. An awful, I would say, policy that many organizations have, instead of, for example, continuously monitoring their security posture, just doing a penetration test just before the release in order to, let's say, patch small things here and there and finish. But this is not the way that this thing should work. Moreover, we want to leave the end users to decide on where the tests are performed, in the cloud or on premises. And one key question is whether you have stressed your pipelines, meaning are you able to tell me that you have tested the tools, for example, planting some vulnerabilities in order to see whether the tools actually detect it? Are consortium consists of 10 partners from 8 member states. As I said, the coordination is from Athena Research Center. It's a 3-year project which started 2 years ago. So, as I said, the core motivation is the drift from DevOps to DevSecOps, trying to exploit the new tools that are coming mainly from artificial intelligence. I don't interchangeably so that we don't have misunderstandings. So currently, I believe that you know several threats. Many of them are quite old. Nevertheless, they require new needs. They imply
Costa, we
new
cannot
needs.
see the presentation. Sorry for the interruption. The presentation.
Sorry, I thought that I was sharing my screen.
Yes, till 1 minute.
Oh,
Ago.
I don't know what happened. Is it working now?
Yes, now it works again.
Sorry
Sorry
for
for the
that.
interruption. Apologies for the
No,
interruption.
thank you. So as I was saying, there are several old threats which are quite well known, and news every now and then appear notifying us that these old threats haven't been abolished. The case of CrowdStrike and this beautiful screen of death that popped up in many screens recently shows that, for example, that poorly tested updates can have devastating security issues, and these can cascade to different sectors of a business, leading to severe issues in the business continuity. There are many issues with credentials management. So apart from having people who are careless and would click on every link that people will send them on emails or social networks, they would. You have also developers who would actually disclose credentials or secrets in their code and the deployed binaries. In this case, we should consider the case of, for example, abuse of an API, because, for example, someone shared the token in the code and has distributed it to everyone. The case of abuse of tokens from for OpenAPI and ChatGPT is very well known and actually created an underground market for that. Or the other case that should be more relevant is what kind of access would an adversary have with the collected credentials? So someone has actually stored the credentials inside the code, and if you decompile a file, for example, a jar, you end up with a Java code and the credentials are there. So what kind of access does the attacker have? There's also the case of software dependencies, with I think one of the very good example being the xzutils, where an adversary not actually tried, but took control of the repository and implanted a backdoor that impacted several thousands of SSH servers. This actually shows how persistent adversaries are, how long they can wait in order to implant a backdoor that can grant them access to many machines, how the human factor can be triggered, the fact that security pipelines that existed in many software houses did not actually understand that there's a problem and that SaaS tools did not work. We're going to test and validate the solutions that we are going to create, that we are creating, in Lazarus in 4 diverse industries: marketing, enterprise software, media and publishing, and IoT technology, each of them having different needs and different audience. But let's start understanding what we want to do. The core for us is that we have a repository that is handled by developers, and they are starting to build the project. So we are creating tools that are directly connected to the repository in order to detect several vulnerabilities. But beyond having this on the repo side, we also are creating a sandbox in order to run everything, to run the deployed solution there. The reason that we want to do it is that we want to monitor what's happening so that we can detect either from the testing phase that something is going wrong and detect vulnerabilities that are going to be reported to the DevSecOps teams, or even when the solution has been deployed and it's released and it's running on the clients, that something is wrong and we have an attack that it's coming. Consider the case that a malformed packet is received and breaks down the solution. So what can you do? These are provided as input to a solution that we are building that creates automatic patches. And if this is possible, then all these are going to the repository, they are committed, and a new life cycle, a new cycle of automatic deploying the project begins, so that the client has the necessary information. Apart from that, because vulnerabilities must be disclosed and reported, we are considering the aspect of reporting this information to CERT, ISACs, so that the identified problem is reported to the proper stakeholders using, for example, MISP. So I know that there are people who are using several tools, whether this is Sneak, Sonar Cloud, SamGrep, or whatever. Nevertheless, many of them are very static. I'm giving an example here showing that by simply renaming a file from .py to .cpp, the rules completely change, and instead of checking the code, which is actually in Python, it's scanning completely different. So people could understand that what's happening here is that someone can probably implant vulnerabilities, or that the way that these tools work is so static that they cannot understand what they are actually auditing. Currently, we have built the alpha version. We are delivering by the end of the month the beta version. So the current version that exists contains a user interface to provide statistics and output of the tools. We have a specialized secret scanning module. We have another module for the software bills of material, some modules which are dedicated to source code vulnerability detection, but also providing patches, and an automated SQL injection vulnerability detection module. I'm going to skip this. These are screenshots from the reports that are provided, but just to give a small insight on what's the story behind, we're using a dedicated trained model on not only secrets, but also code and the corresponding context, so that the model is not able only to understand that there is a leak, but identify the type of the leak. So, for example, you're leaking database credentials, you're leaking mail credentials, automation credentials, web service credentials, or whatever else. So this thing goes far beyond the typical scanning that you would have from scanners that are looking for high entropy credentials, high entropy strings, but it's able to understand what's happening there. For the SBOM, we have a module which is automatically scanning the components in order to understand whether there are valuable components using a well-known vulnerability database, so that you are able to understand whether you have holes in the dependencies. Nevertheless, as I said before, we have two models that we have created in order to perform vulnerability detection, and we also have one more which is targeting on patching. We recently presented some of our work to SORIX in order to showcase how badly some models are in detecting vulnerabilities. There are many issues with AI models in terms of training and how, when you put them out of the comfort zone using different vulnerabilities, they will not understand a thing, showcasing that the training and the dataset that you are using for this kind of models has a big impact on what you can actually have. So this is showcasing more or less the patching, the automated patching pipeline that we are considering. So by the time that someone commits vulnerable code in the code repository, this is this is detected. We have a database with possible patches, and the AI model that we have is trying to create the relevant changes to the corresponding patch in order to provide it and commit the new version. What is coming in the upcoming beta version is the code patching, a language detection tool, because as I said before, most of these tools are very sensitive and very static. We have two tools, one for symbolic execution and one for binary execution. A tool dedicated to vulnerability detections for C. We have a dedicated module in order to find issues with the AI models, a dedicated module for detection of phishing attacks, and a module for information sharing, meaning that the information is sent to the corresponding entities. So thank you, everyone. Please use the link, this QR code, in order to subscribe to our newsletter, and if you want, visit our website in order to join our stakeholders group. Thank you. Hope I didn't exceed the timing.
No, you were okay, Konstantinos. We are running a little bit late, so this is why we're going to skip the break. I was wondering if there are any questions to the presentation of Professor Patsakis. So, Konstantinos, this infrastructure, it integrates to the CI/CD basically, right? So, your customer is the provider of the CI/CD infrastructure or the developer, the software house?
We mainly focus on the software house that is providing the software. Nevertheless, as I said, part of it, since the deployed solution has also the sandbox is also automatically connecting to the developers, so that if there is an attack, if there is a vulnerability, they can immediately understand it and issue the proper
yes,
patch.
but in your server, right? So you don't give me any copilot at the time that I am coding, right? That this might be vulnerable, right? At the time at the coding time, right? I have to integrate, deploy, and then get back the report, right?
So we're not considering only the case of Copilot, because Copilot is when you code. Nevertheless, vulnerability might also might also be apparent when you actually run the code and see what's happening. So Copilot, there's no Copilot there. You have the blessings and you need to do some dynamic, let's say, analysis of what's happening.
So there's a question from Adriana in the chat. How do you measure the effectiveness of the IML tools? So if you can give a short answer and then to move to Testudo and Dr. Ioannidis after your answer, Konstantinos. Thank you very much.
So the quick answer is that we're trying to use more or less the state-of-the-art metrics and let's say methodologies in order to prevent all possible biases, because this is a big issue that happens with many AI models. So we're trying to use the most objective, let's say, metrics, whether this is F1 score or things like that, in order to quantify it. But the important aspect is to use big data sets in order to test it against and try to have the data sets as much as a representative of real world, and not let's say something that which will just simply give me a good score in order to publish a paper. That's all from my side.
Thank you, Konstantinos. Dr. Ioannidis, the floor is yours. Testudo, please do introduce your project and yourself.
Yeah, thank you. I hope you can hear me. Yes.
Yes.
Okay, great. Just give me a second to share the screen. This is it. Can you all see my screen?
Yes, you can put also presentation mode.
Yes, just give me a second. Where is it? Here it is. Okay, so first of all, thank you very much for giving us the opportunity to present some of the key aspects of our project. So my name is Kostas Ioannidis, and I'm here to represent you the Testudo project. So this is some main information about the project itself. My apologies, I don't know. So just to skip and save some time, let's go ahead. What is all about the Testudo project? It addresses the problem of identifying threats in order to protect the European critical infrastructure. against any type of attacks or hazards, at least a couple of them. So the main scope would be to equip the CI operators with innovative technologies in order to improve the preparedness and the early prevention, and to facilitate also the response of the threats. So the aim of the project is to produce innovative solutions for this protection of the CIs in long-term deployment, and to incorporate SOA technologies for the detection, prevention, and prediction of the threats, and in order to support CI personnel in reducing the response time to a threat and minimize potential escalation of the danger. So what the main objective would be is to have autonomous surveillance by synergetic operation. So if you will see the main hardware components would be autonomous platforms, robotic platforms, to improve the detection. On top of that, we propose to use SOA techniques for threat detection, assessment, and risk prediction. And the main scope would be to have increased situational awareness via HMI technologies, and to include solutions in specific use cases. So one use case would be
You're not showing the screens. Sorry to interrupt.
Excuse me, I'm not sharing the screen.
Yes, now we see your slide moving, but please put on slideshow mode, Konstantinos, it will help.
Yeah, is it okay now?
Yes.
Okay, great. So I was saying that one use case would be to have, sorry, it seems that the presentation file has its own autonomy. So we have the scenario of risk of water contamination, where cyber attacks are going to be detected and prevented. The second use case would be to explore the capabilities of the system concerning chemical fires in tunnels prevented by an electrical vehicle. Sorry. And the synchronized attack on water treatment facilities using autonomous platforms, robotic platforms, parallel attacks for water contamination, cyber attacks, and any kind of attacks that would jeopardize a smooth operation of such facilities. So the challenges would be to have cognitive and predictive intelligence, to improve the operational needs, to use different type of sensors, to have low connectivity scenarios, to exploit these type of technologies in non-reachable territories, obviously to implement the acts posing by the Commission, and to have to avoid any violation of AI data protection on privacy tools. So we have included visual detections in order to ensure a 24/7 object detection from visual data, some video streams, the images. The output would be structured data that the detection modules could use, similar detections with a multispectral data concerning thermal images, thermal video streams, in order to support this 24/7 availability using for diverse and weather conditions. Visual object detections on embedded devices in order to maximize use of, in order to maximize the autonomy per se, to use detection techniques, streams, and anything that is related to improve the capabilities. On top of that, activity recognition models will complement the capabilities of the system using raw videos and from visual and multispectral data. As I said already, cyber threat identifications are going to be used in order to prevent cyber attacks, to detect them, to avoid them, and to prepare to increase the preparedness of the corresponding CI operators. On top of
sorry
that, the
again. We are stopped on
similar
slide
case.
use case. You're not passing the slides.
Yes, the slides do not change.
My apologies. It seems that the entire file has I don't know how to resolve it.
No, I think you are showing the slides in a different screen than the one
Now,
you're talking over.
now you can see it at non-presenter mode, I suppose. You can see the challenges, and please correct me if I'm wrong.
Correct.
Now you are
correct.
seeing
Activity
the activity
recognition.
recognition. Okay, in order to
Perfect.
save some time, is it possible to have it as it is?
Perfect, no
Not to have
problem.
it. Okay. So we have the explainable AI for threat assessment in order to present a more comprehensive representation of the outcomes of the AI outcomes to the CI operator and to have a more clear view about the threats that have been identified by large integrated components. So we design and deploy explainable AI models to identify, to present these detection outcomes to the operator and to increase the situational awareness. Also, the prediction models will complement the capabilities and the capacities of the system within the scope of a digital twin for every infrastructure, critical infrastructure, meaning, as you have, I hope you have seen in the previous slides, for the use cases 2 and 3. One is a tunnel, and the other one is for water treatment facilities, including a large dam. What is going to be consumed by these predictive models would be detection outcomes mostly, and raw data coming from sensory systems. And the outcome would be to have a prediction how the detected event could be escalated in order to have earlier response activities by the CI operators. All these technologies and all these components are going to be integrated inside one unique and unified prototype. We are going to deliver 3 types of prototypes, adopting an escalated integration and to deliver the final prototype where all the components and all the capabilities are going to be validated to deliver a TRL7 system. So as you can imagine, and I would like here to stress some of the vulnerabilities that we are going to face, to be honest, because the Testudo project is only almost 1 year active. We are about to test some of its functionalities the upcoming months. So some potential vulnerabilities, as you can imagine, all the system and all the main capabilities of the system rely on the use of AI models. So in order to maximize the autonomy of the platforms and the prototypes, but they are negative. There are some positive outcomes using the AI models, as in all systems, but there are also negative. So we can contribute to vulnerabilities. So not fully accurate as human factor, this is obvious, but they are autonomous, but they could be easily misled. And this is why we selected to have also cyber attacks detection capabilities in order to prevent some of these vulnerabilities. So what will be these possible vulnerabilities in the critical infrastructure? Protection against synchronized attacks, and also in search and rescue scenarios. Obviously, the adversarial attacks, or some malicious data manipulation to deceive the AI models, technically speaking. We're trying to prevent misleading these AI models used by having accurate and including having accurate training sessions and for the AI models, and watching carefully what type of training data are going to be used. So this will also could capture the data poisoning vulnerability, so to prevent the corruption of the training data in order to maximize both accuracy and to prevent this malicious data manipulation. Also to the model exploitation to affect some model parameters to bypass some security measures. In addition, for such systems, we have the system integration risks. So all these integration tests, validation tests are going to prevent these additional flaws inserted by the use of AI models as integrated components to prevent with these tests the AI failures. Since, as you can imagine, these type of flows could eventually drive CI smooth operations to operate smoothly. And also, I think this is obvious, the privacy and the data security. So large amounts of data during the training sessions, so in order to use and to exploit the AI functionalities, could be sensitive. So any type of such type of data could jeopardize the privacy and some security issues concerning the outcomes of the detection models produced by the AI models. To conclude, the Testudo projects, the Testudo project has 20 partners from 10 EU countries and non-EU countries. As you can see that there is a clear focus on the RTOs to produce research and to validate these AI models as it is an ongoing intention by the research community, how well these AI models can be used in such applications. Nonetheless, we have also 6 SMEs and 3 large industries where the clear focus will be to ensure to deliver an actual TRL7 prototype. And this is the consortium of the Testudo project. These are some information about the project. Please feel free to contact us, to follow us in the social media, or to be a member of the newsletter in order to be informed for the project's outcomes. Thank you very much for your attention. I would be happy to answer to any of your questions.
Thank you, Konstantinos. Maybe we can. Yes, there is a question, right, on the chat from Ernesto. I don't know, Ernesto, because you are asking a lot of questions in the chat. If you want just to intervene and make the questions, I don't know.
Yes, please.
Yes, please.
Deep learning-based models such as ANN are not intrinsically explainable due to the highly complex hidden layers and signal propagation.
Deep neural networks are black boxes, right? So which techniques you are used to explain? I don't know, LIME, SAP, or?
to be honest, I'm not the expert for the explainable AI parts, but to my knowledge, one of the approaches that could be used in order to identify what type, where the layers, where all these CNNs converge to a single decision that I have seen, let's say a bomb or something like that, they could use it for the visual data heat maps in order to identify what the exact spaces and the exact patches of the images are contribute mostly for the final decision of the model.
Okay, thank you, Konstantinos. Maybe we can move on to, thank you for the presentation. Maybe we can move on to Dynamic and Sue.
Yes.
The floor is yours. Feel free to introduce yourself, suggest the project, and give your presentation. Thank you.
Okay, thank you. So then I'm sharing my screen now. Yes, please confirm that you can see it.
Yes, we can see.
Yes.
Okay, perfect. Yes. So okay, I need to move back a bit. Yeah, welcome everyone to Dynamic part of the webinar, and together with me, myself is Phu Nguyen. I'm a senior researcher from Sintef, and with me, John from UD in Germany. So we will show you some, I think, some different aspect of our SWA solution. That is, I think in this presentation we are going a bit more specifically to the explainability a bit more because of the double short AI topic in this webinar. So yeah, and John will also jump in at some slide here. So I think so far have been quite some interesting discussion, and I think the explainability have been mentioned a lot so far. So I will give you a bit of the context of what we want to do with that in the context of our project, and yeah, it is quite a lot relevant for the security, orchestration, automation, and response. So if I think there is a common topic for many projects, and you can, I think there is one very nice diagram from these surveys in the ACM computing surveys, that's showing the transition from the manual kind of and passive processes of handling security incident into the SWA, into the orchestration, into the automation, and into the more AI-based solution on the right-hand side here. So basically, what we see, I think in our project, very important is that we, of course, we aim more for automation. We aim more for smart solution. But what is the cons? What is the other side of the coin that we have to be aware of and we have to address as well? So it's not, of course, blindly go on into AI. We need to understand that, so that if you look into here, there are many aspects that can be automated, that can be supported by AI, from the analysis, from the validation to the orchestration and response as well. So we will maybe discuss a bit more specifically on some aspect of basically the pros and cons of our solution here, and how we try to address the cons and especially the explainability aspect. So if we look into SWA, I think the first layer or the first important part is the unification of different security mechanism and tools into the SWA. So the critical infrastructure, they should have already quite some different mechanisms there, but then how to make the best out of those. And then how to provide the continuous security enhancement across the different levels of the system as well. So here in our project, we also want to look into the continual learning approaches, because it is, you know, security is not one stop. We have to do it continuously. We have to monitor it. We have to provide the updates. We have to make the solution that is also more to the evolution of the system as well. So it means there are a lot of new threats coming. There are a lot of challenges that need to be addressed on the fly. So and then on top of that, we still need to support for human in the loop. So There are, of course, a lot of commercialized solutions already available, and you can see there, of course, they are vendor lock-in and then not flexible. If we look into the integration of different tools, how can we make it more generic? There is, of course, a trade-off. If we go for the vendor specific, then it means that it need to go with some specific kind of toolbox there. But then, is there any way to go with a bit higher? More general, so that we can make it with a better flexible integration, and also hopefully can do it more to make it more explainable. So here I think that is kind of a one of the focus that we want to show in this presentation, and we are with the team of this webinar. So we claim that I think quite some current source solution, they don't yet embrace the DevSecOps practices. So basically, I think it means that there is a loop that need to be continuously evolving from the left-hand side of the security development path to the operation phase. And then the context, I think the context is quite key here, because in our project, we take context very important to make the decision based on that, not only the security context, but also the system context that can be provided as well. So those are I think the challenges that we will address in our project, because we want to make the context available for our decision making as complete context as possible. I think the continual learning is already mentioned, and then the explainability is the third point. So the SWAFBC is something called the Security Orchestration Automation Response for Business Continuity. So it means that I think we are focusing a lot on the provide, of course, more automation with the adaptation of intelligence. But at the same time, we want to leverage the context, and that is provided not only in the security tools, the security context, but also the system context from this is the twin that is a backbone in our project or in our solution, so that we can provide a bit more holistic orchestration and with explainability. So that is kind of the focus. And then surely we also want to embrace the DevSecOps practices, so that it is possible to continuously evolve the system, continuously address the new challenges. So you see on the right hand side here are some maybe key aspect of SWAFBC that we base on. So maybe John, can you comment a bit more on the reinforcement learning based approach here?
Yeah, sure. Thank you. So why would you choose reinforcement learning or deep reinforcement learning in the first place? What is the benefit we gain from that? And as we already introduced and explained, we want to have the system context, and we want all the possible data, and we want to have the real-time data that we base our adaptations on. So we have a playbook that we can orchestrate and execute, which actually solves the problem in the best possible way with the most up-to-date data. And the underlying problem, in order to get this result, is the design time uncertainty problem, which basically says it's very hard to predict when and how critical infrastructures or systems in that matter have to change or take an adaptation or threat mitigation or whatever at runtime, because there are two sub-problems that cannot be easily solved, and it is foreseeing all the future states the critical infrastructure is going to be in. And then secondly, for all those possible different states and interactions and so on and so forth, what is the actual impact and effect a certain change adaptation might have on the whole system and other systems as well. And these problems can be solved by online deep reinforcement learning with this continuous inflow of data and taking this data to actually produce an up-to-date playbook dynamically changing over time. What we use architecture-wise is deep queue networks with experience replay, which allows us to use reward decomposition, such that we can split the reward function into multiple reward functions, each dealing with a single different business goal. Most importantly, obviously, availability for critical infrastructures, but there are some other business goals. And what this does is it semantically enriches the rewards we can use or we get for different actions we take and implement, and then we can learn from them. And what it also does is the second problem, or partially solves the second problem that we need to tackle, which I'll explain in the next slide, please.
Yes.
Yes, the explainability, which Fu already mentioned, and a lot of you already mentioned, which we need to tackle as double-edged sword of deep reinforcement learning, or AI in general, solves the problem of design time uncertainty, but introduces the problem of being a black box, like specifically here. And what we can do is we use this data that we just semantically enriched from the rewards, as well as some other specific reinforcement learning data, put them together in so-called decomposed interestingness elements, DINEs, and then have some specific prompting and processing technique, all combined in Chat4xAI, which allows us to use natural language interface in a multi-turn fashion, question answering capability for the human in the loop to interact with this chatbot to find out what is going on and why this playbook was generated at a specific time. At the very bottom, you can see such an example in which we just want to know why was a certain action selected. And we can see already that we can have a contrafactual explanation on why a certain action was preferred over another. And using this semantically enriched data, we can also connect it to the business goals, which gives us clear insights on why certain actions are better than others. And this, maybe just to summarize real quick, is just for the playbook generation. And the second problem now comes in actually orchestrating this playbook and then executing it, and this also making it explainable.
Mm-hmm. Yeah, great. Thanks, John. So I think that is very nice way to show it like from a bit of the top down, because we're starting with the strategic response, and then explain it like you can see here. Then go into the orchestration and go a bit in more the action space, the way we show the explainability of the orchestration itself based on the plan. So you see on this diagram there is a the orchestration, of course, it need to be built on top of integrating different security services that you can see here. And then there's a physical twin that is basically the main system that we are, of course, we are protecting. And then we have the digital twin as the synchronization needed with that. So here our approach, I think it is, I think that the difference with many other approaches is that the twin is playing a role to provide more system context, and also we leverage on the knowledge service. Here it is based on a knowledge graph that can help also with the explainability. So this work actually published recently in this summer earlier. So we can show some key aspect of it. So I think the important part to say is there are some from the unification layer for different security tools. We have the system context, like you can see, supported by the twin. We have the tool-specific context from the security tools, and then of course the alerts and security context that provided so that we can harmonize those into some kind of anomaly reports that you can see here. So this is one of the schemas that we use for explaining the execution and explaining actually what is going on in the orchestration. The second kind of example of another schema for explainability is the logical entities that we use for the runtime also for the enhancing the explainability. So you can there is the context that we can also get from from the centralized knowledge service, and also combining different data sources so that we can have a schema that combining and supporting for the explainability. So I will not go too much into the details, but you can see some examples of such a report when we have it at runtime, so that we can provide explainability at the logical layer of the orchestration. I think time is a bit short, so I will just give a quick example of one, I think one very interesting pilot use case that we have. It is I think it's in the EV charging station context, and here there are quite some, of course, important assets to protect, especially I think the CSMS is server for controlling the whole EV charging station. And then, of course, we need to protect that access. And for example, there are two scenarios that we already experimenting with: the false data injection attack and the denial of service attack here. Those, I think, there is, what we have been doing so far is based on the experiment so far. I think we did quite some different experiments here. But then the insight that we gain from the results is that I think with the combination of the digital twin and the cybersecurity AI-driven SWA, and with the explainability that we try to provide, it could help to involve more basically the optimization of the security orchestration, and with the explainability for the security operators, and putting them in the loop especially for the complex scenarios. So to summarize what we presented so far, I think in this presentation it is mainly focusing on a bit on the pros and cons of our approach, but then maybe more on how we address the cons of using AI here, so that we need to provide more explainability. We do that by consolidating the context from different security aspect tools, and also supported by the digital twin, so that I think even those we of course aim for more automation as possible, but it is still need to get kind of explainability by design from different layers that we can do with the context that needed for that. And not presented in this slide, but there are many aspects of human in the loop that can be also involved. I think we have quite some different components for interacting with the system of operators, so that it is the human in the loop can be supported very well there. And then the runtime explainability. So there is where the security analysis can even analyze the performance of the different security services, so that I think there is something important, because I think for this work, if we go even deeper into the different aspect of security services being used in the system for orchestration, then it can provide more comprehensive views, and it can support also for the explainability. Yeah, you can see more references if you want to understand more about our work. We are like halfway through the project, and of course still many other interesting work that we can do until the end of the project. I think we already have quite some solid results, and I think we can improve a lot on that. If you want to understand more about our dynamic project, yeah, please check out more information from our website here. And yeah, thank you for your attention.
Very much. Very interesting presentations indeed. I have a couple of questions, but I will deprive for asking them for the sake of time.
Yeah.
Maybe I come back to you and Jone offline. And I don't know if unless there are any other questions in the chat, I think we can also, for the sake of time, we can move to Dr. Stojanovic and Rezilmes, and I come back to you offline.
Yeah, thank you, John.
Dr. Stojanovic, please take the time to share your presentation, introduce yourself, and introduce your project. We can see the presentations. Thank you.
Hi. Thank you. I hope you can hear me also.
Yes, very clear.
Yes. Thank you. Yes. First, thank you for staying at this webinar, although we are a little bit late in this number. I'm Branka Stojanovic. I work at Ioneum Research, an RTO in Austria, second largest one. I work for ECSCI Digital, the one that deals with different digital technologies, and we are highly involved in resilience systems, in disaster resilience, but also in cyber resilience, but we are also involved in machine vision, in audio systems, and so on. One of our projects is actually Mars rover. So here I'm going to present Project Rezilmesh. and my presentation is about edge-based anomaly detection and enhancing performance and sustainability of cyber attack detection in critical infrastructures using edge-based technology. So just a few words about our project. I will skip through these slides because we are a little bit late. It is Horizon Europe program project that will last 3 years. We have 14 partners from 9 countries. The main objectives of the project include delivering an open and extensible security operations platform, then providing advanced cyber situational awareness, enabling detection and response capabilities, managing security and resilience in complex dispersed digital services, and support for diverse infrastructures. Our partners are balanced between research institutes, research organizations, and industry and end users. Our main use case providers are in the field of robotics and in industrial production. Then we have one smart city use case and one with critical infrastructures with the power distribution company. So these slides I will just skip through very fast. So what challenges are there? Because we talked a lot about it today. Main challenges that inspired actually work on this project are that modern digital infrastructures are complex with a lot of infrastructure layers. Then they are heterogeneous, where diverse technologies increase the range of potential attack vectors, and they are dispersed. They're spread across wide geographical areas, and which actually weakens traditional perimeter-based security. And that's what inspired our work on edge-based attack detection. Additional challenges are that cyber attacks are becoming more complex and sophisticated, as we saw in one presentation before that was about advanced persistent threats. So I will not go into detail about this. And another one is that organizations are slow to adapt security systems to evolving digital architectures and infrastructure. These challenges usually require adoption of techniques like zero trust and secure systems edge. And here it is necessary to address increasing distribution and complexity of systems. So some guiding principles from Resil Mesh are actually in connection with the NIST regulative. We grouped our resiliency techniques in 3 major groups. One is contextual awareness, and here we are working on resource awareness, on mission awareness, threat awareness, and risk-based response. Then the second group would be coordinated protection dynamic positioning of adaptive response. Here we work, how we address it. We are addressing heterogeneous infrastructures. We are also working on flexible functional allocation and composition and on orchestration. And the third group would be analytic monitoring. Some approaches that are involved here are sensor fusion, threat monitoring, forensics and behavioral analysis, and situational awareness. Here in Resil Mesh, we, Ioneum Research, are leading threat awareness work package and work in threat awareness. And on this image, you can see where it fits in the whole Resil Mesh framework. This is the architecture of our framework, of our system practically. Here we address different data sources as endpoints. So data sources that give different types of data. So not only network traffic, we also consider log files from different endpoints and the sensor readings in OT systems. Then there is aggregation plane to aggregate all of this data and send it to process the data, extract meaningful features, useful features from it, and send it to anomaly detector. And this anomaly detector is something that I'm going to talk about today here. Resil Mesh, in Resil Mesh, this pipeline continues actually to anomaly correlator. We are also working on correlation of different anomalies in the system. and discovering different attack patterns. So here I will talk about our results applied on a voter distribution system. I have to say that this is a theoretical work for now, and within ResilMesh we don't have voter distribution company as a partner, but we have a voter distribution company from Graz as our partner separately in some national initiatives, so we plan to test our results also there. So this is a presentation of theoretical work because it is a critical infrastructure of great importance. So here what we did, we used different data sets for this with sensor readings from a voter distribution network. And we tested out first centralized anomaly detection approach and then edge-based detection approach. With edge-based detection approach means that we divided the network geographically and virtually placed, so to say, detectors in, at 3 different edge areas. These detectors independently detect anomalies within the system. Here you can say why we did not choose maybe federated learning, but this is a bit different approach because we have different, completely different. It could be that you have different endpoints at different edge areas here. So this approach fits better for this work. Why we did it? First, because of environmental impact and efficiency, because it you can get reduced carbon footprint through local processing. But also, what is also enhanced is localization of attacks and events within the system. Because with centralized detection, it is not that easy to localize where something actually happened. But with this, it improves that challenge. So we compared edge-based detection to centralized detection, and here what we got actually a little bit of reduction in overall performance due to smaller number of features used and due to some loss in information because voter distribution system has a lot of interdependency between different nodes as such. But as response, in addition to localization and as I said, and energy consumption reduction, we also got a reduction in the mean time to detect attacks, meaning practically that attacks are detected, not that they can be localized, but they are detected faster within the system with this. So regarding the carbon footprint, here we got 75% emission reduction in training, of course, but that's not the main issue in general because you don't do training on a daily basis maybe in the system, but regarding inference or using the system in a live setup, we got reduction by 2 orders of magnitude. So that's a significant reduction, and it is actually something that drives our research in this field. But it's not the only thing that we did that we are working on in this project. In addition to detection of attacks, cyber attacks that originate from some malicious users, we are working on securing AI systems. And here the challenges are that although AI enhances cybersecurity by detecting attacks or analyzing different behavior, broad AI adoption also brings new security challenges and introduces new attack vectors within the system. So just briefly to mention what are possible attacks on AI systems. There are adversarial attacks that manipulate input data to deceive the model, and then in this example here, that's not related to water distribution, but it's very self-explanatory. As you can see on the stop, when you have automated detection of stop sign in automotive driving, for example, with some just small amount of noise, the stop sign could be completely misclassified. Then data poisoning, that includes injecting malicious data into the training set and corrupting the learning process with this. Then there is a model extraction as a type of attack here. This is the reverse engineering of models by querying, and this can lead to stealing intellectual property. And the fourth one that I'm going to mention is model inversion, that uses model outputs to infer sensitive training data. And this can also lead potentially to violating privacy and confidentiality. The type of attack that we tested in our use case in water distribution intrusion detection system is adversarial attack. Here we created the adversarial, we tested first I want to say we tested the white box attack. That means that's the type of attack where the model and some details about the AI model are known to the user, to the attacker. And here we created adversarial samples and added this. We created some small amount of data like noise and added it to input samples. And with this, as you can see on this image, a lot of attacks. The green fields actually present the time frames when the attack occurs within this data set. And with this, not all, but 4 out of 7 attacks stayed below the threshold. So they would not be detected in this way. And we use our system for this testing. What can be done to improve robustness of AI systems? First, training data should be clean, should be safe and secure. Then some risk assessment methods should be performed here, especially regular risk assessments of AI systems. And technically, what also can be done, it's adversarial training. That means to analyze data and to add adversarial samples to training data to get more accurate decision boundaries. We tested out some of these methods, and with this, we again improved robustness. We improved robustness of our detector, and with adversarial training, actually we got all attacks detected, regardless of adding these adversarial perturbations in the input data for inference. So, to conclude, I also want to say this is ongoing work from our side, and if someone is interested in more details, I can share with you our papers on this. I would like here to stress the importance of security measures for AI systems. It is essential to safeguard models and to include testing, validation, monitoring, and methods like adversarial training to your systems. And of course, to regularly assess and update measures and to adapt to evolving threats. This is what is driving our research. So I would like to thank you. I hope I didn't take too much time.
Thank you, Branka. Also, I would like to thank you twice, because this is the first presentation that we heard also about the vulnerabilities of AI, right? Like the evasion attacks and how they can be alleviated. I don't know if there are any questions. If not, I think we can move to the final presentation of Atlantis Project and Artemis. Thank you, Branka, and consider this opportunity. I don't know if you want to give us a 2 or 3 pages description, and also to document and include the solution for the Knowledge Hub.
Of course, yes.
Last but not least, Artemis, you know, it's a long webinar, so we are missing few of our audience, but I invite you to introduce yourself, your project, and give a proper presentation of Atlantis and AI.
Thank you very much. So first of all, can you see my slides? Everything is fine?
Yes, I can.
Okay, thank you. So, hello, I am Artemis Voulkidis. I work for Synelit Solutions in Greece. And today I will be presenting the Atlantis approach for what concerns the AI at the service of CI protection at EU level. I am the technical coordinator of the project, and I will start by providing a short project identity card. So our project was related to the cluster 3 call 1.1 of Infra 2021. So safeguarding European infrastructures against systemic risks. We are a quite large consortium, so 38 partners out of 10 countries. We are already in month 24 as we speak, so we have done a lot of things. And I'm going to share some of those today. So overall, according to the call, of course, our mission is to improve the resilience and the protection of interconnected European critical infrastructures against evolving systemic risks. And when we're talking about evolving risk, we're also including hybrid risk, coordinated attacks, so risks related to coordinated attacks, as well as cascading risks. And we're handling both a cyber and a physical part. Our main target being to guarantee the continuity of the operations of these critical infrastructures. So I will start by providing an overview of architecture and how AI is deeply, let's say, integrated in this architecture. I'm going to keep it at ultra high level so that I don't waste your time. So we're starting from the critical infrastructure assets, which we continuously monitor. And of course, the critical infrastructures of Europe, they are not unprotected in all this race of security. So they have their own physical security and cyber security intrusion detection systems, and quite a lot of times they also have intrusion prevention systems, even though they are mostly kind of static. So what we do is gather as much information as we can, both raw data and metadata from these IDS and IPS systems, as well as the raw data I mentioned before. And we move all this information stream into a high-level, let's say, component called Situation Awareness and Comprehension Framework. What we do there is to analyze via machine learning, CIP processes, etc., the risk posture of the critical infrastructure, and then provide this risk estimation, let's say, so the state of the risk awareness that we have, to another component called Risk Reduction and Incidents Mitigation Framework. So these are sets of components at local CI level. All the blue things here are local CI level. So this framework, the Risk Reduction and Incidents Mitigation Framework, again, performs some sort of processing. I'm going to talk about the AI part of that later on. And then it produces sets of countermeasures, recommendations, and policies, mostly at post-crisis level. So when we apply this outcome of the Risk Reduction and Incidents Mitigation Framework, this gets back into the IPS systems and then the critical infrastructure assets, essentially creating a closed control loop between the asset monitoring up to the situational awareness, the risk mitigation, and back into the assets. At the same time, there is a second level loop, let's say, that serves information from the local CI level, so the blue boxes, up to the pan-European level, where we have defined cross-CI knowledge sharing, risk assessment, state awareness, and incident mitigation framework. It's a long title. Mostly, we should consider that this is a pan-European entity, let's say, that gathers abstracted physical and cyber security information, so cyber physical threat intelligence, let's say, and operates against this data as if they were local assets. So for the pan-European part, the various collaborating, let's say, critical infrastructures, they're like assets. So we actively, let's say, apply more or less the same closed control loop that we use at local CI level, also at pan-European level. Now, AI is presented, let's say, in practically all the layers that we have. So we start from the risk detection, prediction, and valuation of the risk. From the IDS part up to the awareness and at pan-European level, pan-European awareness at this point. And then we get back also applying AI at the risk mitigation, let's say, part. So from the pan-European to the local CIs, and from the local CIs down to the assets. In the next couple of slides, I'm going to have some examples of how we employ mostly machine learning, but not only machine learning, in the local CI and the pan-European level. So at local CI level, I have carefully selected 4 different examples of using AI. We have a couple of more actually, but I could not fit them into the presentation. So the first one is a threat intelligence tool that uses mostly NLP techniques on top of data that get acquired from social feeds, news, etc. And in particular, a component that we have that checks for disinformation campaigns. So granted this functionality, we get information from the real world, let's say, not CI level. And we try to understand what is the general environment that our CI works in, again, through NLP techniques. Then, granted all the network asset equipment that each critical infrastructure has, we are performing active network traffic monitoring. We're using graph entropy and machine learning to dynamically assess the network topology and the changes, of course, of the CI and predict the device's uncertainty based on its connections and placement, so that we can then apply intrusion detection via anomaly detection, of course. Then another critical aspect of AI that we use is related to GNSS interference detection. Actually, our project has a task that revolves around how can CIs adapt to changes in the networking infrastructure. So, for example, we don't have any GPS, or we don't have timing, or we don't have any kind of backbone infrastructure. How do we detect and how do we counter this? So in this direction, we are applying CNN classifiers on top of some spectrograms from devices that we deploy in the LSPs. And these spectrograms, they provide us with GNSS signals, which we assess using statistical features of raw samples that we have. So we have an introspection period, we get some data, then we elaborate on the spectrogram that we get real time, so that we can understand whether we are having GNSS interference. And in these cases, we can spawn up 5G or satellite, let's say, communications. Last, we are having AI on the risk reduction and incident mitigation framework. Mostly what we do here is to gather information from relevant risks and threats that had been identified before, and what were the decisions that were taken by the stakeholders each time. So what we do there is to apply LLMs to create model of proper, let's say, responses to risks and threats, so that we can have post-crisis recommendations, policy recommendations, and mitigation suggestions. On the lower side of the screen, we can see high-level, mostly, figures of how the AI is incorporated in the threat intelligence tool and the GNSS interference detection. Before I will move on with the XAI, I would like to explain very, very quickly the objectives of explainable AI it has been discussed before in this webinar, so I will be very, very quick. We use AI in Atlantis to justify the decision-making of AI models. So we have an omnipresence, let's say, of AI in the system. We don't exactly know how all these recommendations for the risk data awareness or for the mitigations have occurred. So we need something to enhance the transparency throughout this whole AI lifecycle of Atlantis. So this is why we use it. And why we would like to have such an opportunity, let's say, twofold, of course, increased trust in AI decision among the various CI stakeholders. So this could be the CI operators or certain LEAs or this pan-European entity that I mentioned before. And of course, increased trust and increased transparency leads to enhanced collaboration among different AI systems and also not AI systems as well. So what do we do in the context of explainable AI? We have three different approaches. So the first one is, we call it PGGraph plus EVAXplainify. What essentially does is to assess the impact of, it's targeted on CNNs, and it assesses the impact of each CNN cluster and highlights the most critical ones. You may see an image on the right side of the screen where the neurons of each layer are displayed as clusters. And if I would zoom in, which I cannot right now because this is just an image, this would expand and each neuron would have a different size, and the size would explain an increased, let's say, or decreased impact on the decision taken. Then we have XAI for X's, which is an end-to-end XAI framework. It's mostly relevant to data point explanation, dataset explanation, and it can handle quite a big range of modalities of data through LLM, so Llama. And we have a very interesting approach provided by our colleague Surf related to machine unlearning. So we have AI, machine learning, and unlearning. So what machine unlearning does is to leverage on interpretability techniques for efficient model correction. And its goal mostly is to remove privacy and security violating information within pre-trained models during their life cycle. So it actually exposes the risk so that we can be better prepared about that. At pan-European level, things are not very, very different, but there is also a kind of a different approach. So at pan-European level, the entity that I presented before, it may act as a federated learning aggregator on cyber-physical threat intelligence, let's say, data. So we use it to enlarge training data set of CIs. This is mostly on network data because the rest of the data sources that we have were kind of heterogeneous, so it was kind of hard to combine everything. Then, based on the data that we get from the various critical infrastructures, we are performing anomaly detection at federation level, so classical learning on federated level, on federated data, and we use that using LSTMs. So the target here is through anomaly detection to identify cascading and coordinated attacks. At the same time, and since the local CI loop is kind of replicated on the pan-European side, we have actionable alert generation, again through LLMs. And this is not purely LM, but we are also holding information regarding ISAC and shared data mining. So we're having instances of MISP, which we tend to connect to the, for example, the Melcertes network, and perform some data mining on that so that we can assist the rest of the process that we run, particularly the second one, so the anomaly detection on federation level. Of course, again, we're also having XAI as much as possible also at pan-European level. So this is it for the technological part. I have listed here some opportunities and challenges. So of course, the opportunity is that we are in the position to provide enhanced cyber physical security through CI interconnectivity. So the pan-European part is really, really important. but at the same time, it poses a significant challenge, most related to confidentiality and safety. And it's a question that I also posed before. It's kind of hard to have stakeholders collaborate by sharing data. So the opportunity now is also a very big challenge. Another opportunity is, of course, the alignment of AI with legal and safety standards via efficient model correction, and this can be assisted by explainable AI. However, the challenge here is that the XAI methods, they can pose potentially privacy and security risks when exposing them in turn, let's say, to the various stakeholders. So I will stop my presentation with some conclusions and lessons learned. So our conclusion in Atlantis, at least, is that AI can significantly enhance the CI protection and assist decision making when it comes to application of countermeasures and relevant policies. And key components of our framework, they demonstrate the effective use of AI in predicting uncertainties, managing crises, and detecting threats. Some lessons learned that we have, they are mostly related to explainable AI. It's very, very crucial and can significantly help building trust. And the main opportunities that we identify is that AI can bolster cyber physical security, and it can help us align with legal standards through improved model correction and interconnectivity. So that's it. That's a very high level version of how Atlantis uses AI to ameliorate its offering towards the relevant stakeholders. So thank you very much. Please make sure to visit our website and feel free to contact us whenever you see fit. Thank you very much.
Thank you, Artemi. Let me ask, we lost some of the audience, but let's see if there are any questions for you. And thank you for putting, also some of the challenges, because this was part of the webinar, and actually only you and
yes.
And a little bit of Branka did that in the end, right? And this is also, Artemis, something, at least from a EU-CIP perspective, we get this feedback, right? So don't tell us only AI capabilities, tell us also about AI-related vulnerabilities if we introduce into CI AI.
Exactly, and the biggest challenge everywhere is the lack of data. Everybody's talking about ML and AI. The willingness of the stakeholders to share data is always the biggest challenge. And what we claim in Atlantis is that through XAI, it may be, let's say, rendered a bit easier to make them, actively collaborate towards the goal that we have.
Yeah, I think we have discussed this in other occasions, right? And we have also tested different solutions. The thing here is that if I have a vulnerability or a security incident and I am a critical infrastructure, I'm not happy to share it, even in the end if something happened, because it's something that I wouldn't like, other my business partners, for example, to see. Anyway, thank you very much for the presentation. I say we are a little bit over time, but not so much, 10 minutes than the planned time. I would like to thank all the speakers and all the projects for this webinar. I think I've talked about other opportunities, so you will hear from us at EU-CIP and ECSCI Cluster very soon. Also about the book, also about the opportunity to document your solutions, also about these mini proceedings if you want to do it. And we will be sharing with all of you the recording and with your permissions, the presentations for the community, okay, in PDF format, initially through our Knowledge Hub. Then, of course, you can take and give it through your the dissemination channels of your project. Once again, thank you very much. Thanks to the audience that make it for the full 2 hours. I think it was a successful webinar with more than 85 people registered and more than 50 in practical attendance. So see you in our next event. Thank you very much for contributing.
Thank you, John. Thanks, everyone, for a great event.
Thank you very much. Bye-bye.
Thank you very much.
Thanks for the
Thank
opportunity.
you.
Thank
Bye.
you.
Yeah, goodbye.
Bye.
Bye.
Thank you. Bye-bye.
You give it to me? Okay, I'll give it.